Okay, we are going to look at your trigonometry and area worksheet. And I am going to look at number 2 to start with. Okay, so we have to find the area of these triangles. And so number 2 will give us 5, 6, and 140. Okay, so area of a triangle is base times height divided by 2. So I'm just going to let 5 be my base. And we have to find the height. So what we need to do, the height is your straight up and down distance. So what we can do is make a right triangle over here. It's my right angle. Here's my height. And I need theta in this right triangle. We have a 90-degree angle. I need to know what this angle beside the 140 degrees. And if you'll notice, these are supplementary angles on a straight line. So 140 plus 40. So here's my angle for theta. And now I can use trig and we're going to find our opposite side, which is our height, and we're given the hypotenuse here is 6 on this right triangle. So opposite hypotenuse, we're going to do sine of 40 degrees equals, opposite is my height over my hypotenuse. All right, let's cross multiply these. So we get our height equals 6 times sine 40. Now, in the calculator, let's punch in 6 times sine 40. All right, so my height is 3 point to the nearest hundredth is 3.86. Okay, so we were trying to find the area of this original triangle here. So we said our base was 5, and so 5 times my height of 3.86 divided by 2. All right, so let's do that. 5 times 3.86, and then that divided by 2. So the area of my triangle is 9.65 square inches. All right, now let's look at number 6. So number 6 tells us a triangle with two sides that measure 6 and 8 with an included angle of 137 degrees. So the 137 degree angle is going to be in between your two sides listed, 6 and 8. So 137 degrees, that's an obtuse angle. So something like that, 137 degrees. It doesn't matter if we let 8 or 6 be the base. Let's let 8 be the base. And we'll let this side be 6. Okay, so here's my triangle. All right, so my base is 8. We need the height. So straight up and down distance. And we need theta. But if you'll notice these supplementary angles, 137 plus 43 makes 180. So theta is 43. And now I can do trig. So we have a right triangle. Theta is 43. We're finding the opposite side, or my height. The hypotenuse is 6 over here. So we'll do sine of 43 equals my height over 6. cross multiplying, we get our height is equal to 6 times sine 43. So my calculator, let's do 6 times sine 43. So to the nearest 100th, I get 4.09 for my height. Okay, so area, base times height divided by 2. Area equals my base of my original triangle is 8. So 8 times 4.09 divided by 2. Area, okay, let's do that. 8 times 4.09, and that divided by 2. So the area of my triangle is 16.36 meters squared. All right, now let's look at number 12. These on the back, 9 through 14, are regular polygons. Regular polygons, if you'll remember, means that the side lengths are exactly the same length. So that gives us the bottom is 9. All these side lengths are 9. And also, all of the angles inside of the polygon, if it's a regular polygon, are the same measure. But what we got to do is find the total degrees in this polygon, and we did that a few weeks ago. And then we'll do something with that to figure out what we can do for theta. What I'm going to try to do is, if we split this angle and we make a triangle, then I can find the area of this triangle. And if the bottom side is 9, I know half of it is 4.5. So from here to here is 4.5. But I need this angle. That's what we got to figure out to find the height. So we're going to do total degrees first. And if you remember, total degrees of a polygon, if you'll take your number of sides and then subtract 2 and multiply that times 180, that'll give us the total degrees. So our total degrees in a hexagon would be 4 times 180. And that's going to be 720 total degrees inside of our hexagon. And I'm going to divide that total by 6 because there's 6 angles that I see. And if we divide 720 by 6, we get 120 degrees in each angle. So like that angle is 120, that one's 120, that one's 120. Well, remember, I cut it in half right here. So my theta is going to be 60. All right, now we can do trig to find the height. So the height of my triangle, we're going to do tan 60 equals my opposite over adjacent, so height over 4.5. So my height is 4.5 times tan 60. So let's do that in the calculator. 4.5 times tan 60. I get, for my height, 7.79. All right, so the area of this triangle, the main triangle, right there, area equals base is 9 times my height of 7.79 divided by 2. And that gives me 35.1. Okay, but how many of those triangles are inside the hexagon? Well, if you drew them out, there's 6. Okay, so the area of this triangle, the one triangle, is 35.1 times 6 will be my answer. 35.1 times 6. So the total degree, or the total area of a hexagon with a side length of 9, a regular hexagon with a side length of 9, is 210.6. And that one's in centimeters.